today. My name is Don Endress. I'm the CEO of Novita Nutrition, and we're very pleased to have the opportunity to sponsor this software optimization webinar with Dr. Mark Hanigan and Steve Martin. We, again, appreciate your participation today. As most of you are very familiar with Dr. Hanigan and his impressive research over many years, I think what I find most interesting about Dr. Hanigan is that he's both the practical experience of operating a dairy and early in his career, and then he's, part of his professional career, published 170 peer-reviewed research paper on dairy nutrition, and has been a member of the NASEM 2021 Dairy Nutrient Requirements Rewrite Committee. So very involved with dairy nutrition, and just really pleased to have him here today again to talk about optimization. I think you'll find his presentation insightful and useful, and really help continue to improve dairy formulations and overall improve dairy economics. Before I turn it over to Dr. Hanigan, please note this webinar is being recorded. We'll also be distributing a link to all the registered attendees for later reference. And Dr. Hanigan and Steve will be taking questions after the presentation. Because we have so many joining today, we're going to start off with everyone's mics muted. That'll save from any background noise. But then we encourage you to unmute your microphone and ask questions and make this a very interactive session. Also want to let you know that you are eligible to receive 1 continuing education credit for participating in the webinar today, and you can search for the meeting on the ARPA CEU site titled Optimization Webinar by Dr. Hanigan and Steve Martin. So yeah, if you have any trouble finding that, just let me know. We can help you with that. So with that, I'll turn it over to Dr. Hanigan.
Excellent, thank you. I need to make sure and remind or at least acknowledge the funding, because the USDA in particular gets a little cranky when we don't. So this is partially supported from a USDA grant, and it's funding some work that we have ongoing now for the next couple of years. So I want to acknowledge their contributions. So the first question we should probably ask, given the title, is I don't need to use a stinking optimizer. I can do this by myself. Why do I need this? And so I like to sort of point out that there's some psychology work that was done a number of years ago by a group, and it ended up in sort of what's called Miller's Law. Now, whether it's really a law or not, I don't know, but essentially what they found was the human mind has the ability to sort of keep in place between 7 and 9 pieces of information and manipulate those. So when we look at this optimizer problem, for the dairy diets, we've got more than 250 ingredients that we commonly have access to and use. And we're now up to probably, somewhere around 50 nutrients that we're looking at. So if we multiply those two together, we got 12,000 plus numbers that we're trying to put in our mind on the input side. And of course, we've got another set of 250 feed costs and some information on the income side that we need to consider as well. So I'm not, maybe, people look at me as a fairly good mathematician. I don't think I'm that good, but I definitely know that 12,250 is a lot more than 9. So we're not able to do this really in our mind. We have to have help to do this if we really want to reach the optimum. Okay, and we'll come back to that in a little bit. But, of course, the way you can get your nutrients down a little bit in terms of trying to chunk this up into problems is, first you can solve for the vitamins. We don't consider all the feed ingredients anyway as sources for those, nor for the trace minerals in general. And so you can, you only have a few ingredients that you use to meet those 2 needs. And so you can piece those off, right, and do those first and get it down by about 13 or so. It gets it down to about 36 nutrients. And then you can ask, okay, well, how important are some of these other ones? Maybe I could ignore some of those. But, when you start looking through the rest of the list, there's not a lot of them that you want to give up, right? And so maybe at best you get it down to 20. Well, 20 times 250 is still way more than 9. So no matter how we piece this problem up, we really can't get it to a point where we can do it in a perfect way without using some help, okay? And that's what computers are for. So first question, if I back up again, is maybe I can get rid of another 6 if I get rid of those darned amino acids. Who the heck came up with all those and starts loading my plate up with that? Do I really need to worry about those? And so I would, make the case with this slide here, and if we focus on the columns, it's looking at different ways of solving for diets, okay? And how well does the model, in this case on the left-hand side for the first 4 columns, it's the NRC 2001, or the last column on the right, the NASA model, how well do they do in predicting animal performance, given a diet, okay, and given a nutrient supply? And if you look at the NP allowable milk in the first column, then it certainly does come close to the average, right? If the observed mean is out of these 900 diets, basically the observed mean was 900 um, grams. I've got kilograms, sorry, grams of milk protein, and the predicted is 951 from that model. And it tracks, somewhat well. In other words, it's not bad prediction. The root mean square prediction error, in other words, when I predict 919, it's plus or minus 21%. Okay, so you got about 180 grams either direction that you're looking at for variance, which is not the best. The mean bias is okay. What's the problem with this approach is the slope bias is bad. So if you're at 80 pounds of milk, that's about the center of the data, and you're fairly well centered in the data then. But if you go up to 90 or 100 pounds of milk, the model will start over predicting requirements. And likewise, if you go down the other direction, which I'm not sure why you would do that, but if you find a low herd you need to work on, it's probably going to under predict requirements on the other end. If we look at the NE allowable, it's sort of the same story. I mean, it has about the same error, and it has a similar slope bias. And if we put the two together, which is generally what we do, looking at first limiting nutrient, it doesn't fix the problem. Okay, I mean, the error is still the same. We still have the slope bias, and so it's not the best model to use. It just has some fundamental problems with how it depicts the biology that's there. And if we start adding in not essential amino acids, it makes it worse. Okay. So we get bigger and greater errors on this. And so what we did is we sort of threw out that and came up with a different approach where we integrated 5 of the essential amino acids and energy into a sort of a better representation of the biology. And we got a pretty good pop in precision, right? We halved or almost halved the precision, the error of prediction. We got rid of the slope bias. I mean, this number is not significantly different from 0, and so it's a better prediction if we use those 5 amino acids rather than using MP. And so it's not that MP is bad. It's just if you're trying to do a really precise job, then using the best models, and then which are generally the newer models, is going to help you. And so just hitting it home a little bit with pictorially, I mean, here's what the data looks like, the predicted and observed data looks like from that equation, which is depicted up at the top up here. And so we have, in this particular one, I have threonine in as well, which I think we left out of the NASA one, but it is significant. It's just sort of, not real well defined. But we have histidine, isoleucine, leucine, lysine, methionine, and threonine, plus then digested energy. And digested energy is the biggest driver, okay? It still makes up 2/3 or more of the drive for making milk protein. So you can't, if you have low energy, you can't fix this with amino acids. And so it's a better way to go, and I would encourage you to try to make it use of these kind of approaches, because if the model's not right, then the rest of this, 45 or 50 minutes that Steve and I are going to put on is really not that useful, right? I mean, if we can't diagnose pregnancy in these 2 individuals, then we're probably not going to need an optimizer to help us, get the best solution. So what does this process involve, from more of a math standpoint, okay? And I'm not going to dig into a bunch of formulas. I'm just talking about concepts, okay? Trying to use pictures. So it is a mathematical problem. It has 3 parts in terms of defining the problem. And then we use a 4th piece of math and code to actually solve the problem. And so the first one is the objective function. What are we trying to achieve here? In the past, we've almost always looked at, minimizing diet cost. So we have a model where we plug in, we want, 90 pounds of milk at 3.1 protein and 3.5 fat. The model then will back calculate to what the MP and ME, will be required to meet that, and maybe some other nutrients as well. And then you're actually using then the supply model also within the system to predict, okay, well, what if I feed an ingredient, what's the MP and ME supplied by that ingredient? And of course, I have these 250 ingredients, so I want to choose the combination of those that meets all the MP, ME, amino acids as a ratio to MP or to energy or whatever, way you're reflecting your amino acids and the vitamins and minerals. And I want to minimize diet costs when I do that. I'm not trying to predict how much milk I'm going to get. I'm saying this is what I want. The second way you could look at it is one that's probably better for long term is, okay, well, how about I want to maximize my margin, right? I've got an income from milk and from growth, and I want to subtract off cost, and I want to maximize that. And that will, actually, particularly if it's a little bit of a nonlinear model, which our models are today, then that actually will give you a slightly different answer than minimizing cost. And looking forward then, I mean, we would like to think these environmental problems are going to go away, but they're not going to go away on their own. And it's likely that, at some point, not in my career, but probably in some of the younger people's career, that an environmental impact cost will be assessed on some of these things. And so that can be built in to the objective function as well. We then have a set of inputs, right? So we've got all these ingredients that we can use. We've got the specifications for the nutrients. We got the cost. On the cow side, we plug in how big the cow is, what breed she is, the age, the body condition score, days pregnant, days in milk, et cetera. And it uses that to calculate maintenance and some of the efficiency values. Of course, we plug in production, which would be growth and milk production, right? And reproductive growth as well, so a calf growth. And it will then either calculate or will specify what the composition of that product is. And we're going to provide some values for how much that's worth. How much is a pound of milk protein worth, and how much is a pound of milk fat worth, or how much is milk volume worth in the Southeast, since we don't actually do component pricing yet. And then if we go forward, then maybe we'll have some other costs that we'll load in as well. So that's our inputs. So we got objective function and inputs. And of course, we got constraints, right? I mean, we can't just let it solve for out of the 250 ingredients, whatever it wants to use willy-nilly, because we're going to have some feed availability problems, right?
I need tomorrow at 5 p.m. to pick up Bronson's content.
So we have feed availability in terms of on farm, right? I mean, the farmer only has so much forage harvested and stored. Now, maybe he has a lot of extra, and so you don't have to worry about it, but often you have to constrain how much of the forage is of a particular forage that you can feed over a certain period of time, how much grain he has in the bin, and whether he has any contracted ingredients. Okay, you can't contract and then not use those ingredients, so you need to use them. There's palatability issues with some of the ingredients that have value, blood meal and fish oil being a couple of those that we have to be cognizant of and make sure that we don't feed too much of. We also have some animal tolerance issues, right? I mean, we can't feed 12% fat in the diet. The animal won't tolerate that. We can't feed 20% fiber or 10% fiber for a very long period. The animal won't tolerate that. She won't tolerate too much starch either, probably more from the fiber standpoint than from starch. And the trace minerals all have toxicities, and the vitamins have toxicities as well. So we can't just let those go to whatever they want. We have to make sure we have those in biological bounds. And, of course, we have some constraints on nutrient use in terms of the requirements. And I've only listed vitamins and minerals, but, we can still look at it, with the linear models and say, okay, well, we have requirements for amino acids and requirements for energy and fiber, et cetera. So all those things can be constrained to actually hit the nutrient range that we want that's allowable. And then, of course, if we want to constrain environmental impact, which if you're in Florida and you're working in an area where they're tested for phosphorus in the water, well, then you're going to certainly constrain that because you don't want to let that run up above the bare minimum that you need. Another example might be bulk density. You know, if you're feeding a bunch of loose hay, then maybe it just is too bulky and you want to keep that constrained. So lots of reasons why you might constrain, but they should all be valid reasons, okay? Not just ones because you don't like some ingredient. So given those, the optimizer then manipulates the inputs to try to achieve minimum cost if we're doing a diet cost objective function, or to maximize profit, subject to the constraints. And it tirelessly then searches all combinations of those inputs that lie within the bounds that we've set or the constraints that we've set to find the best solution. And that's generally, minimally dozens of iterations to perhaps thousands of iterations. So if you're back there still thinking, okay, I can do this myself, all right? Well, how many tries are you willing to make? I mean, if you make 1,000 or 2,000, you're probably going to get pretty close to the optimum. But how long is that going to take you? And if you don't do that, then you're leaving money on the table, okay? There's probably less than a 1 in a million chance that you would accidentally land on the optimum for any diet. So we're leaving money on the table if we don't use these. So let's look a little bit then at how the linear optimization is solved. And this is a really sort of neat set of equations. There's a neat approach that was developed in the 1930s, late 30s and early 40s, and it was used extensively in manufacturing and logistics and so forth. And of course, we used it for diet optimization in the starting in the 60s up through the late 80s into the 90s before we started switching to CNCPS and then NRC 2001, which had some nonlinear components in them. And essentially, the neat thing about a linear one is that the bounds, which are these red lines, so we've got two inputs, X1 and X2, and it is sort of, they're trying to depict a three-dimensional one here. So it's actually sort of coming out at you, or back away from you, whichever way you want to look at it. And so you're looking at a point that's, the farthest, the closest to you or the farthest away, depending on how you want to visualize the third dimension. And because it's linear, the neat thing that this fellow discovered or thought about was, well, we only need to check the corners, okay? So in this case, we only have, 1, 2, 3, 4, 5 corners. The best solution is always going to lie at one of these vertices. Of course, all the area within the red is all feasible region. And that's where you're landing with your diets when you do them by hand. They're perfectly valid diets. They're generating milk. They don't hurt the cows. They meet the cows' requirements. There's nothing wrong biologically with the diet. They just don't fall on one of these vertices that's going to generate the least cost or the maximum profit for you. So it's really a nice approach, and it's it would be nice if we could stay forever in this linear range or this linear space, because it provides all sorts of neat information. And Steve's going to touch on some of this later. And certainly there's ways that they try to take the curvature in equations and cut it up into small pieces and then use an iterative approach to walk, from one vertex to the next. Even though it's not linear from E to D, for example, if we take little steps at a time and go part way, we can follow the curve using a series of linear segments. So there are ways that we can still use this. It's a little bit more tedious to set up the code to do that. And it doesn't really matter how many dimensions this has, okay? It does become a little less efficient as it gets larger dimensions, but then people have come up with ways to try to attack that to keep the cost or the computational cost down. So the problems I've already hit on are one of them. Some of our functions in the models are nonlinear. And so examples out of the NASM one are the ruminant available carbohydrates, a nonlinear equation, the microbial growth equations, nonlinear. And there's some nonlinear components in terms of growth and milk protein responses to amino acid and energy that we're representing with quadratic equations. So they're still linear, and capturing the nonlinear portion, but they're problematic because you have to scale those things all the time. And so that's what that 305, mature equivalent milk protein is for. It's trying to scale a couple of those quadratics so that they actually work. And so this is a problem as we go forward, that, continuing to stay with linear models is going to introduce error, and it's going to introduce more error. I guess the error is going to stay the same. It's just that the ability to get the precision you want is going to improve as you go more and more down that nonlinear range. And, also the conversion from net nutrients to absorbed nutrients is not constant either. There's interactions there that are difficult to capture in a linear format, but certainly easy to capture in a nonlinear format. We have some substitution effects. We have some efficiencies that's influenced by other nutrients, and we have diminishing returns. Okay, and that's probably an important part in terms of looking at marginal cost or marginal returns versus minimal cost or maximal production. It costs us more and more to get additional increments of production as we go up that response surface. And in the past, at least, we've typically ignored income. And again, if you start looking at those diminishing returns, then getting that last few increments of milk or milk value is not worth the cost. It costs more to get that. And so, again, we can't accurately reflect those if we don't have proper representations of those responses. So if we then look at nonlinear optimization algorithms, there's two general approaches that are used. One is based on a gradient, where it's looking, it doesn't know where it's at, but it looks, sort of a little ways away from it and says, is the slope going up or is it going down? If I'm trying to climb the mountain, in other words, maximize my profit, well, then I want to go up the slope. Okay, so start trudging up the slope. I don't know what it looks like, but I can trudge up. And so these approaches, that are gradient based are sort of what is being depicted in this little animation here, where it starts off in this flat space out here in sort of the middle of nowhere, and it's near this hill, and so it starts using an algorithm to climb up that hill and find out exactly where the top is. The other approach that can and is taken is what's typically categorized as an evolutionary approach. And in that case, it says, okay, look, I'm just going to brute force this with the machine, with the computational power I have. I'm just going to do a whole bunch of different starting points all over this grid. Okay, I got 240 ingredients. I'm just going to look at a whole bunch of combinations of all of them and try to get an idea of what the field looks like. Okay. And then, you can start combining those and saying, okay, well, I got, everything around the edge is bad here. It's all low. Okay. So we can contract a little bit and we can get into the first ring here. Okay. And then we're going to look and see, okay, well, the middle of the first ring is still bad, but I've got these points around here. And so it can actually go around and start looking at combinations of solutions that are better. And eventually then it will arrive at the tops of each of these hills. And then it can measure, okay, well, which hill is actually the tallest hill. But of course, it can tell you, that they may be really close to one another. And so all three of those hills might be really good solutions, okay? Perfectly valid. And I don't know this for sure, but I think that's what NDS does with its nonlinear optimizer, because it always gives you multiple solutions, and it does take it a little bit of time. So I'm guessing it probably uses an evolutionary approach. The gradient methods, require smooth objective functions. We had problems with our models, but I think we've got most of those sorted out. It approximates the local surface and climbs the mountain. And the success in terms of finding, the real optimum depends on where you start. So this one's always finding an optimum in that lower left corner, right? Because it's starting very close to that, and it's finding that slope. It's not finding these other ones. Maybe these other ones are better, actually, the other three hills. And so if we don't start it over by one of these other hills, it's never going to find one of those other hills. It's always just going to climb this hill. So we have to actually start it at different points, different starting points for your diets to try to ensure we get the optimum solution. And so that's a problem with this, because you can end up with lots of minimum solutions and no real true maximum solution, okay? And the more ingredients and the more nutrients you're looking at, the more of those little hills you've got. So that's a little bit of a frustration. And that's large, so we don't know whether when we get a solution, if it's truly the best solution. It's a good solution, better probably than you got by hand, but it's not necessarily the best one. And the evolutionary methods, basically avoid that problem. It just trades in lots of computation time to try to map out the whole surface and then find the best one. So by and large, if you're willing to wait a little bit for them to get done, they're going to ensure a better solution in general. So in summary, we've looked at nutrition models. They continue to get more complex, and the reason they are is because they generate more realistic diet simulations, which leads to better diet solutions. And the amino acids, as I pointed out, are not more important in energy, but they are important. And the fatty acids are being more and more used. And of course, our knowledge is continuing to grow on those. And so, again, they're not going to replace energy as the primary driver, but they're going to provide more precision and more control over what you're doing to try to make sure that we're actually getting the best performance and the most optimum returns that we can. And again, from Miller's law, the human mind can only hold 7 to 9 items at a time. And so even if we, with these 12,000 variables we're trying to manipulate, we can't do this by hand and get a optimal solution. We can get good solutions. They're certainly feasible. They're not going to get you in trouble on the farm, but you're leaving yourself subject to someone else coming in using an optimizer and undercutting you by 10, 15, 20 cents. So, I think that's likely. Usually when I see diets that come in from the field, when we optimize, we can usually get 10 to 30 cents more. So I think that's generally a representation of what's being left on the table. So in the future, unless you're going to retire in the next couple of years, then use an optimizer. These are problems that computers were designed to solve, and these algorithms were designed to solve them in as little time as possible. Yes, it takes time to learn it, okay? And it may take you slightly more time to solve a diet in general. But there are some tricks that help, minimize that time. And so I think Steve's going to cover a few of those. And it'll help you find that extra 10 to 20 to 30 cents. And so the question I'll leave you with is, aren't your customers worth it? Okay. 10 cents a cow is a pretty big deal, right? 30 cents is a really big deal. So, you deserve, I think your customers deserve the best you can do. And this is a tool that will help you do better. It doesn't replace you, doesn't replace your knowledge. It doesn't know really anything about nutrition other than what we code in, okay? It's not, an all-encompassing solution to this. It still needs you to guide it, but it will help you in that guiding process get to a better solution. So with that, I'll stop, Steve, and turn it over to you, and I'll stop sharing here and Don can introduce him.
Yeah, thanks, Mark. Yeah, that's very interesting, very helpful, and I have a number of questions after listening to you describe the differences between the nonlinear models. But yeah, so we switch over. Just a little background on my connection with Steve. Way back in September of 2017, Steve and I met at a Starbucks in Fort Collins, Colorado, to work on diet formulations. And I just found his deep knowledge and almost exclusive use of software optimization to build his diets was very unique. Now, there's a number of nutritionists that use them, but at least at that point in our life cycle, he was one of the first that I met that really knew how it worked, used it on a regular basis, and had very good success, very good results. And so over the years, I've relied on Steve to help Novita optimize diet formulations as a service to some of our nutritionists that were formulating NovaMeal. And I think you'll find Steve's presentation very interesting and helpful, and his examples of how to use the optimizer, how he sets it up, and some of the challenges. You may see some of those today, and as well as some of the opportunities. So with that, I'll turn it over to you, Steve.
All right. Hello, everyone. I'm coming to you today from Trenton, Florida. and appreciate the opportunity to work from one of my clients' offices here to have a good internet today. So, yeah, I'm really excited to be able to follow Mark's presentation. Mark and I have been talking about models and optimization for, I don't know, maybe close to 20 years now. And I'm really pleased to call him a friend in the business and really been a mentor to me over the years. And then Don is right. He and I have had a special bond over building diets in the last 10, I don't know, almost 10 years now. And so he's been very encouraging to me to kind of go out a little bit and start talking about this and trying to, yeah, help the industry be better. I think, yeah, I mean, got a lot of competitors on the call here today, but we all work in the same industry, and there's a lot of work for all of us to do. And I think we need to feed cows better, and we have some economic things to think about. And then Mark mentioned some non-economic things that can also be optimized for. So start out by showing a picture. I spent a lot of time as a kid building fence, and I grew up in Alabama, so there would have been more trees in this picture than this one, but this is very similar to the type of fencing we did. A lot of five wire barbed wire fence to keep our beef cows in the pastures as much as possible. And then my first job off of our own farm was at the beef unit at Auburn when I was in school at Auburn. And when I was working at that beef unit, my first day there was about the first day that I met my first person I probably ever met from Kansas. And it's a K-State guy that had a master's in beef, and he's coming down there to work on a PhD at Auburn, and he was given the management of the beef unit. So I showed up at work on my first day, and he wanted me to go fix some fence. And so the blue dot down there is where I would have built fence in Wetumpka, Alabama, and this orange dot is Auburn, where he's having me build fence on my first day at work. And he gave me a set of tools that almost none of which I'd ever seen before. And I looked at him and I thought, I really don't know what to do with any of these tools. These are different than the way we build fence in Alabama. I know you're from Kansas, and that may be the way y'all build fence in Kansas. But anyway, he's the boss and I'm not the boss. And so I take his tools and figure out some kind of way to try to build fence. And so what he gave me was one of these fence stretchers down here in the bottom right corner, and I'd never seen such a thing growing up. We were more like the picture on the left, except instead of that fancy blue nice deal there with lots of good leverage, we used a claw hammer with as big a claw as possible, and you would grab a barb and pull that thing around as hard as you could, and then someone else would grab a staple and a hammer, and you put that staple right behind the barb there that you thought would hold, and that's the way we built fence. But I learned how to build fence differently, and I remember thinking specifically, when, not that it gets that cold in Auburn, Alabama, but when he showed me how to take those two wires to join them and not work at the post but work in the middle and join them in two U's like that, I'm thinking, yeah, this is never going to work. The first time it gets cold this winter, these fences are going to break. Well, turns out those fences were just fine, and I learned that there was more than one way to build fence. So the reason to tell you that story is that all of us are tasked by our clients or our employers to build rations, and there's probably not any of the two of us that do it the same way. And even within our group, we really try to kind of do things the same, but we just don't. We all see cows a little different. We all focus on different parts of forage analysis a little different than other people. And so I want to just say today that there's a good chance that some of you are just as good as me at this task and at the optimization part. And it could be that maybe there's some that have not played with it a lot and have some stuff to learn. But starting with the Pearson square up there in the left corner, and then looking at these other software packages that are out there. And my quick story is just over on campus from the beef unit there at Auburn, I had a professor named Elvin Thomas that taught a feedlot nutrition class, and he taught us to optimize in a program called Mix It in about 1985. And it was a very basic linear programming, linear model solving optimizer. And what I remember about that class is he wouldn't let us leave class and literally out the door unless we had a feasible solution. So we got really good at figuring out where we were stuck, and he would help us get unstuck so we could go to our next class. So now, these 30 some plus years later, I've remained passionate about using this way to feed cows. And now we have all these pieces of information and science to help us do it better. But the math is, the math is the math, and Mark's way better at that than me. So we'll always remember that. So one other point I want to make, I'll let you study this map for just a second and make some sense of it. This is to make the point that things that may be very important and true in Ithaca, New York, may or may not be very important or true in Blacksburg, Virginia. And that's not a dig or a negative on either one of those groups of scientists. But I think it is important to remember that these models are not exactly the same. And I think as tacticians like we are, we have to understand both and kind of look at how to use the NASEM and the CNCPS and kind of take that plus our experience and find a way to feed cows better. All right, so a couple of starting principles, and Mark hit some of these. I'm just going to fly through these so we can get to NDS. You know cows better than your computer does, okay? Your computer does math better than you. The computer can consider more things at once than you can, which Mark said. The computer can more quickly reference scientific principles, nutrient requirements, nutrient information quicker and better and with more accuracy than you can. This number 5 is a little bit challenging for me to think about, but the computer might be more creative than you. Okay, you can help it. The two of you together can be creative, probably more creative than either one of you by themselves. And then the last one I'll think is to go to the trouble to do all this. It's really important that you have accurate forage analysis, and it's maybe even more important that you actually have really good analysis on byproducts on things that may be in feed libraries, in various software packages that may be different in your neighborhood. So make sure you have those right all the way down to the rates and the KDs and the 30-hour NDFDs, all that stuff begin to matter a lot. All right, so you really need to start easy and then get complicated. And this is something that I learned in college on doing this all these years ago. You need to describe the animal correctly. If you're balancing a ration for some high cows that are kind of peaking, like a breeding group, giving a lot of milk, make sure you tell the computer all that you know about those cows, and really think about number 2 here is think hard about intake levels. For the models to really work well, you have to be as close as you can to what a cow's weigh. Are they gaining weight? Are they losing weight? And are they pregnant? Are they not pregnant? How pregnant are they? And how far they walk? Are they in big dairies where they're walking a lot? Or are they in small dairies where they're not walking much? And those things begin to matter. And intake is obviously a very big part of that. But even still, within those, I still have clients that have cows that just shockingly eat different amounts of intake. And so sometimes I end up focusing more on concentrations of nutrients than amounts, because the intake thing is just a head scratcher sometimes, and the concentrations I think are a little better to anchor. When you think about nutrient groups, pick one nutrient that represents each kind of nutrient group. So on energy, pick one energy. Pick a protein number to start with, pick a fiber number to start with, and then you can begin to drill down and fine tune those things. And then a note about vitamins and minerals. You can use these optimizers to really nicely build vitamin mineral packages to save a lot of time. And I don't do that a lot, honestly. I tend to build those, and then I use selenium as the nutrient then that sets the feed rate of that vitamin mineral ingredient into the diet. And then I look at the resulting numbers, and if I need to tweak it, then I go back into that mix and move things around. So those are some quick things to start with, and some things not to do. Okay, things like don't ask for a calcium minimum, and don't and at the same time not offer limestone as an ingredient. Okay, you're going to get an infeasibility if you ask it for something on the nutrient side that you didn't give it an ingredient to solve. And a similar thing to that is if you do find yourself like having minimums on vitamins or trace minerals, those things are in a mix and they're at a set ratio, so you really can't start picking and choosing between those in the optimizer unless you want to open up that mix, and that just gets a little hairy. Sometimes we ask for similar nutrients with incorrect relationships, and maybe not, maybe even dissimilar nutrients, things that go opposite each other. And so there's times that you may ask it to do something that's impossible because you've got two nutrients that go opposite ways from each other that it just can't mathematically get there. And then lastly, and Mark said this too, is just don't give up too easily. And so before we get to the NDS, I just want to make sure, Mark said it, we're going to use the linear optimizer today. We can perhaps do this again with a nonlinear optimizer. It's just a totally different approach. And but what I found in my real world use is, I will tell you that I think I use both of them. I use both the linear calculations, and then I use what I would call the nonlinear CNCPS predictions, and we'll look at how we do that in a minute. So I use the linear to kind of look for different rations we can feed, and then I look and see how those look in the CNCPS predictions. There's pluses and minuses in this approach, and I'm sure I'm going to say some things today that Mark's going to shake his head at and say, yeah, you're wrong on that, and I'll say, yeah, I know I'm wrong on that, but I'm right on these three things. So the question is can we build a better ration using some level of optimization than we can without it? And I think that the answer is yes, you can build a better ration, you can target more nutrients, and you can do it for cheaper. Okay, but you can't give up too early. And sometimes the whole thing goes off the rails, which could happen today. Okay, so yesterday I was wondering why I agreed to do this. And I hope this goes well, because if you've ever played with optimization, it's a little bit like having your kids or you, when you were a kid, taking a really well-trained show heifer into the show ring, and everything went really well during the training, and then you get in the show ring and everything just goes to pot. And that could happen today. So if it does, then we'll just be documenting reality. Okay, so what I got for you here in NDS, we're going to look in this tab right here that I've got ABC Dairy High Ration. And this actually is a ration from a dairy that is that I feed. And I've added a couple little details to make it more useful for today. But like I said, it's very important that you describe the animal correctly. So I've got this animal described. This is actually a dairy where there's no heifers at this particular location. So I put about, I think in general, we don't know how much our cows weigh. At least I don't know much. I mean, we can use like cull cow weights and stuff like that, but we still don't know as much as we should about what cows weigh. We certainly don't know what their body condition change is. I'm interested in looking into cameras and things like that to try to be better at that. I know there's some scales that are showing up in the industry that interest me a lot, but what I've got right here is a big cow, big mature cow, somewhere in a breeding pen. Maybe she's 125 days of milk. And I'm going to model it kind of at the average of that pen at just under 100 pounds of milk with a 401 fat and a 338 protein. And so this ration is very similar to what we're feeding at that dairy, and these cows are milking very similar to this. They're in the 106, 104 energy corrected type milk range. The whole dairy is probably certainly a little bit longer in days of milk than that. And so it could be that maybe these cows that I'm trying to model actually are eating 64 pounds and they're given 112 pounds of milk instead of, right at 100. But it's very important, really important, that you keep this ratio of intake to milk correct. And so you can just constantly, it shows you the conversion somewhere. Somewhere there's a feed conversion on here, but you can just do it quick. And we do it all the time when we're walking around in pens where you got a pen giving 110 pounds of milk and they're eating 58 pounds of feed. It's like, oh shoot, these cows are converting it to 1.8 or whatever, and you feel really good about it. But make sure you're not going to the trouble to do all this math and you have some crazy feed conversion that's either really too good or terrible, to make sure that that the things work, because I think those things have a lot to do with rate of passage and some things like that. So, all right, so this ration is a corn silage based ration, ground corn, sorghum silage, soybean meal, soy hulls. This is the one difference. This dairy does not feed alfalfa hay, but I stuck some hay in here because my dairy roots were from out west, and I just wanted to stick it in there just to play with it a little bit. We tend to feed a little cottonseed, but not a lot. You know, right here, I probably should have picked one of these two, a low fat or a high fat bypass soybean meal. So just consider those to be together. In fact, let's just do that. Let's just make that this is more of an amino plus type soybean meal as opposed to a soy plus. I'll just move that half a pound over there. We have some palm in here. We've got the high stearic prill. We got a splash of urea. And then we got just a little bit of, you know, real modest uses of some rumen protected amino acids, and then some Alamet in here as well. So what I like about this setup as our example today is that these cows are kind of milking real similar to this ration, real similar to these kind of milk results. All right, so what I would do if I was working in real time to take this current ration and see what I could, let's say that forage analysis change, or I get pressure from my clients like, hey, I really, you know, margins are tightening. I don't know if y'all been reading the news, but tighter margins are coming. So it's been a little while since we've had a lot of pressure on feed costs, but I'm afraid those days are fast approaching. And so I think sharpening our pencils on finding feed cost savings that are smart are probably in our near future. And so it's a good time to start playing with the optimizer. So what I do in this situation is I would copy this to a new scenario and work on it in there. Okay, so if you click this optimizer button right here, you're going to go to the screen that basically is this ration, but it is shown here with other ingredients and things like this. And the reason I had a backup plan here is when you copy these over, sometimes all the time you spent setting these minimums and maximums up for this specific diet, sometimes they just disappear. And this today in our trial run for this, they absolutely did what I hoped they wouldn't do, and they just flat up disappeared. So I could take the time to re-enter them. I do have you can save kind of a base standard number for these. But what I'm going to do today is that standard base number for these nutrients really isn't as critical when you're going from this ration to the next ration, because if you like the way the cows are milking, you like the manure, the components are where you want them, everything's just pretty good, but you have to make a forage change, or you're running out of a contract and you've got to make a change even though you don't want to. You might say, look, my main goal here is just to make sure that I can make a ration change and supply the same nutrients that we're supplying today. So when I do that, then I go through here and I look at where these actual numbers are. And I'll go over here and I'll unclick this dry matter, unclick this right here and make all these go away. And then I'll go through here and I'll click the ones that I want to work on first. Instead of doing them all, because then you're probably going to fail, click, like I said, click an energy one, click a protein one, click a fat one. And then you go over here and start looking at ingredients. So I would normally go to a save as function, and I would always click this thing here to open in a new tab so that you could see both. You could toggle back and forth. I'm not going to do that today because my numbers aren't here, so I would just end up getting another one with a blank spot here. So I was smart last night when I had this working well, and I saved one that does have those. So basically, this is one I created last night from that same ration, and in it has my optimization nutrient goals. So if you have questions on that, we can circle back to it. This kind of housekeeping stuff, and maybe I'm doing something wrong that makes it go away, and Jacob or Dave or somebody could help me out of that, and I'd sure appreciate it. But you can see the things I've got clicked over here. I've got ME, I've got forage %, I've got NDF, I've got 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 100% 1 I've got UNDF. Now, I told you I've already broken one of my own rules. You could actually just take 40% off and just, if you like to kind of use UNDF 240 as a modulator for forage quality changes. I think it's a pretty smart idea. I always click starch, and sometimes I do sugar. Depends on if I'm feeding whey. If I have whey or permeate in the dairy that's really cheap, I may put a maximum on sugar. I usually start with a 5% minimum on fat. This ration currently, I'm gonna toggle back to the current one. The current ration is 5.02% fat, so that's pretty even move. And then I will, like with butterfat prices where they are, I'll find myself routinely putting a minimum on 16.0 fatty acids. If that market falls out of bed soon, then I probably will take that off and just kind of go back to the crude fat and ME to drive that. But I usually also then put a maximum on 18.2 fatty acids. Okay, so you're going to see when we optimize this that it's going to bump up against that. So you got to decide whether, distiller's grain or brewer's grain or something that's pretty cheap, whether you're okay using more, and you might say, okay, well, if I let this go up a little bit, what's my cost savings? Or the other way around, if you've got depressed butterfat and it's like, man, everybody else in the world has good butterfat, but I don't, maybe it's because you're feeding too much distillers or brewer's grain or hominy or something, and this 18.2 fatty acids may be like at 2/2, and you could say, okay, let's drop it down to 1.75 and optimize again and see what the feed cost will be to accomplish that. And when you have other fat sources available, it tends to very nicely move fat products around, and the fat part's really pretty straightforward. The protein part is as well. I think in the Southwest, we tend to feed probably maybe a little higher crude protein levels. I know maybe in the Northeast. I saw some recent MUN data by region, and it was shocking to me how low the MUNs were in the Northeast. So good job, y'all that are up there, really being way better at nitrogen efficiency probably than we are in the West. You can put a soluble number in there. I think thinking about soluble and RDP, what's the MUN on the cows right now? Do you like what the MUN is? If it's running too high, maybe you want to push some of that protein a different direction. Okay, so this is where I tricked the system a little bit, because in the model I used to use, which was AMPS from Provimi, in this linear list of nutrients, there was a metabolizable protein, a metabolizable methionine, and a metabolizable lysine. And as Mark said, those are not linear nutrients. But I think what has happened in that model is they kind of chopped up the curve a little bit and picked parts of that curve that are mostly linear. And I think, in my view, it worked very well for me to move those numbers around in that nonlinear nutrient and crammed into a linear box. And so what I found, just nobody taught me this, I just figured it out, and someone might say, oh, you're doing this wrong, you should be doing this instead, and I'm all ears for that. But I found if I manage RDP reasonably, and then I use RUP3X as a knob, right? I mean, I don't know what 7. I have no idea. I mean, we all know what a 10 RDP means, and we know what a 17 protein means. I have no idea what a 7.35 RUP means. That's just a number that if I go back to the current ration, that's kind of where it's at. And if I like what's going on, I'm going to nail it right there too. And so what I find is, if that seems to be the most valuable number to move NP allowable milk on the CNCPS side. So if I want to increase NP allowable milk, I increase that, and you can then say, okay, I'm going to decrease RDP a little bit, or you can say I'm going to let crude protein go up. So I think each person can, if they play with these and take time, I think you can figure out how to manipulate this NP allowable milk in a good way that is meaningful. Because so down here in what I'll call the CNCPS box, I changed this nutrient list for a handful of reasons to my list. And the first thing I go look at, so these are very similar to, if you go back to the, I'm going back to the previous ration now, very similar to this box right here, okay, in the center, that basically shows your ME and NP allowable milk, and then it kind of shows on lysine and methionine. You can add things here. You can look at ME, metabolite or methionine per mcal of ME, which is obviously a very important number nowadays. So this box right here, when you're in the optimization screen, is lives down here in this bottom right corner. It's not you can customize this. There may be something you like to watch that you can add to this. So when I look at this, I obviously you don't want red, right? So red's bad. But ME supply, MP supply, and I've already optimized this because I did it last night, and we'll play with it again, and you can see it move. But you're going to look at these numbers, and you're going to, in my view, when I look at these numbers and I feel good about them, it gives me more confidence that these numbers over here are right. Because as Mark said, there's some especially the higher you go up in milk, these numbers begin to fail a little bit. And so I'm still probably not going to put a ration together that has a lower NP allowable milk than my current ration if I like what's going on. But if it goes higher, and then some of these numbers over here look like, yeah, it may say it's 102, but these numbers over here look suspect to me. So then I'm going to discount that number. And in fact, the model that I'd used before this actually had some tricks like that, where it would over predict NP milk, and you could go over and it gave you a score. It's like, yeah, you're probably over predicting NP milk by 3 pounds because you're short on RDP, or you're short on this, or you're short on that. And so I kind of take that same approach and use these numbers down here to determine how much confidence I have in this number. Okay, so let's pretend that we just copied this over here, and I go through here in my ingredients and I say, yeah, we can feed up to this much corn silage based off inventory, ground corns, whatever. We have 5 pounds of sorghum, no more. You can pick between NovaMeal and gluten and distillers and soy hulls, and maybe you don't have a zillion commodity bays and you need to kind of get rid of some of this stuff. But I just wanted to show a lot of opportunity. This dairy feeds wheat silage for part of the year and sorghum silage for part of the year. So, if you wanted to model the other half of the year, then you could use the wheat instead of the sorghum. I like to offer straw. Maybe it's grass hay in your part of the world. I like to do that because there's times that if you're, especially out west where we struggle sometimes to meet our roughage minimums, that we really have to make sure that we have an opportunity to solve a ration and not be too low in some of the roughage numbers. So once you get your mins and maxes where you want them, go up here, click this optimize button. And after you optimize it, the first place your eyes should go is right here to this box right here that has the 100 in it. And the reason that's where you have to go first is if that box is red, that means that you did not meet a feasible solution. So back in my college class, I couldn't go to the next class until I got this thing to be not red and 100. Sometimes it'll be 99.992. It's like, well, yeah, come on, it's close enough. And then you can tweak something and get it to solve. But this is you need before you're going to go really look in the ration, make sure that you've got a feasible solution that's not red. And then you can go down here and start looking at, look at the feed cost. So basically the ration we started with was 773. This one has solved at 760. It's like, okay, well, that's nice. That's a nice feed cost savings. It's kind of in the range that Mark talked about. I don't see a lot of 30-cent savings, Mark, but I see lots of 10 to 12s. And so maybe every once in a while there is a 30. So if you look at what it did to compare to the other ration, we can show it side by side in a minute and see what it does. But what if, I guess I want to show you a little bit of the functionality. I don't think the other one had gluten in it. Okay, so gluten's not a great buy this year, really, because distillers cost about the same, but maybe the distillers is bumping up against this 18.2. So maybe the RDP and gluten is a good deal. So I'm going to double click on this green dot right here to take the gluten out of contention. Okay, and then right now we're at 760, and then I'm going to optimize it again. And that without gluten, it went up 4 cents. Okay, so, and also when it does that, it gives you what the shadow price is on gluten is $205. Okay, so the shadow price on gluten is $205. It tells you it would come in less than that. It's obviously way less than that. But, you can play around with this as much as you want. The other ration didn't have NovaMeal in it. This NovaMeal is a version we've been working. Stands for Van Amberg CNCPS. We've been working with Mike's lab to try to better make sure that we're characterizing that with a zillion MSPEs and UNs at his lab. And so that's the one I used for today. And since they're sponsoring this, I just thought I'd point that out. But if I disallow the NovaMeal in this one and I optimize, then it went back up about. So really, honestly, and I promise you, I didn't set this up this way. The NovaMeal is one of the big changers in finding that feed cost savings. So let's optimize it. Let's let it pull that. It's still pulling soy. What did it do with the bypass soybean meals? It dropped out the Amino Plus type one. It pulled in a little bit of the soy plus one, which is interesting because with the higher fat bypass soybean meals, they're going to bump up into this 18.2. So if I went in here and said, hey, I don't want more than 1.5 18.2 fatty acids, my guess is it's going to flip those. And it didn't. It must have reduced something else. Maybe it reduced distillers. So I'm going to put it back at 1.65. I'm going to solve it again to get back where I was. So we got this 765 compared to 773 start. If I had a chance to add an ingredient, if we could add the corn gluten back and drop it another nickel. Okay, so every once in a while you ought to stop and make sure that you're not all red here. Okay, and make sure that these numbers are still, right under 100 pounds and they all look pretty good. We ended up just a skosh under 1.1 on the methionine. And since you don't have a methionine nutrient to drive, if this is going to keep you up at night, just go over here to your RP methionine and just put it at 0.04 instead of 0.035. Optimize again, and there's your 1.1. Okay, so what you basically did was you said, I'm going to be at 1.1 because I've been on 500 of these webinars and podcasts, and that's where they tell me I need to be. You're not going to be able to drive that with the linear nutrients. You have to drive that on the ingredient side. And what I would say is that when you forced it over here as an ingredient, it still found the cheapest way to get you to 1.1, or cheapest way to use that. And I would say the cheapest way to get you to 1.1. That may not be exactly true, but I think you get the point. Okay, so let's say that this is the ration that we've settled on, and we looked up and down. It's like, yeah, this looks pretty good. I'm surprised it didn't drop out the cottonseed at $300. That's crazy. Another example of this is math you can't do in your head, right? So I know we're up against time, so I'm gonna cut over here. You have to save it first, and then we're gonna get to the point where I can let you look at this side by side, and then I'll probably pause and see if anybody's still on the call after the top of the hour and has any questions. So you got to go back to the ration you started with, which is what we call this high ration. So I'm going to go back to it, and then I'm going to go to the comparison tab. And basically the comparison tab is going to put your old ration on the left-hand side, and you go to compare historical, and you find the one that we just did, which is right here. And it should populate in there quickly. And just to make sure we're looking at the right one, you can find this RP methionine that, yes, we forced it up. So this is the right ration comparison. This is a great screen. It shows your kind of average milk numbers here for each one. It shows you we saved a dime in feed cost. Here's your NRC type nutrients, NASEM nutrients. If you want to see the CNCPS numbers, you click this. You can look at allowable milk, and you can go and you can look and see whether any of these things worry you. Actually, and if you look at methionine, lysine, and histidine, actually it is backwards a little bit, and that doesn't surprise me because the lysine number was a little low. But what I've learned from Mark's lab and the stuff at Virginia Tech is that when I can work with things like branched chain amino acids and look at more of a core 5 or at least a total essential amino acids approach, this right here doesn't bother me any. And these cows that are milking like this at that dairy have this situation going on, but we have a lot of the total essentials in really good shape. So a lot of good numbers here. You can look at the amino acid if you want to look at these details on amino acids, and you can begin to see them where you can look at total amino acid supply. Reds are things you're down on, greens are things you're up on. If you want to look at the branched chain amino acids, you can go down here to the bottom. If you want to look at what's coming from bypass versus what's coming from microbial flow, you can look at it right there. And then I really like to go down here and look at these ones that are ratioed to energy, okay? Because these are the ones that I think matter to me the most. So if I look at methionine to ME, it's really solid. I don't see the total essentials to energy. I don't know if it's in this list, but we looked at it on the other screen and it was actually even. So this is where I go. I like to print this, and there's a zillion ways you can print these and show the things you want to show. And you may get to this point, you may say, "Oh shoot, I didn't see that." And if that happens, just go back to your optimized diet and fix whatever it is that worries you when you looked at that. So I missed this, and change a minimum or max, or change a minimum or max, and then you can run it again, look at the numbers here, go back to the summary side by side, and see if you fix the things that you're worried about. So I'm going to pause. I know we're 5 minutes over, so I'm interested to minimize my screen and see if I'm still here talking to myself or not. So awesome. There's still 33 people here. Thank you. Don, are you going to referee some questions for Mark or I?
Well, I can sure give it a try. I guess you covered a lot in a short period of time. I feel like I'm drinking from a fire hose here, but it's yeah. Maybe you could talk a little bit about some of the confounding parameters. We talked in the past a little bit about crude protein on a TMR basis versus focusing on MP. Sometimes those are confounding. That might be helpful.
Yeah. So if I am I still sharing now? Yes,
you are.
So. I mean, I'll let Mark talk about it in the nonlinear world, but in the linear world, I mean, in my view, obviously crude protein is as linear as it gets. You see, have a minimum of 16, and I've got protein levels in here on every one of the ingredients, and we know gluten's not the same every time. I will say NovaMeal is very good numbers there on a lot of samples to Cumberland Valley, but corn silage changes, and it may only go from 7.5 to 8.2, but if you're feeding 22 pounds of it, it's going to matter a lot. Whether your ground corn is 7.5 or 8.1 matters a lot when you're feeding a lot of it. So you really gotta live and die, I think, by MUNs and milk protein and maybe some TMR samples. And I'm just not gonna run these low crude protein levels on a big dairy out west where we're blowing through loads of hay like nobody's business. I'm gonna build some cushion in there, and I'm just gonna make sure that that I don't get caught. And maybe I pay more attention to MUNs than I should on that. But I think that you can successfully play around with these numbers and make your MP allowable milk where you want it, and then look down here and make sure that these amino acids are at least close to where you want. Mark, you have a different view?
You're muted, Mark.
Sorry, obviously I shouldn't be even on here because I can't even figure out how to unmute the mic. So. I don't think I would disagree. I mean, MUN certainly is the bottom line, right? I mean, it's telling you how efficiently you're using protein. Yep. And so, if it's too low, then you have less cushion, and like you said, if you've got a lot of variation coming through your feed supply because you're going through the hay faster than you can analyze it, then you're at risk, right? I mean, you really don't know what it is, and you don't know what it's going to be tomorrow. You might know what it was yesterday, but that's not helpful anymore. So yeah. So yeah, I mean, you have to look at it as a risk management thing as well, and that's another thing I think that people I think generally do a good job on is having more ingredients with smaller inclusion rates is less risky. Okay, when you start putting your eggs all in one or two baskets, that's a risky thing to do.
Which is what we do with corn silage in most modern dairies, right? We have a lot of eggs in that one basket. Yeah. So I mean, if you're not sending weekly samples into corn silage, you should. And one more point on the MUN is I'm a real big proponent lately of string samples for components and MUN. And if you've got multiple rations on a dairy and you're trying to use the bulk tank to decide whether your crude protein and your protein setup is good, you might be surprised if you did that at least in early, mid, and late lactation. You might have a different answer on whether you're doing that correctly or not.
And when you get that number, it doesn't tell you how to fix the problem if you have one. It just says you have a problem. Go find it. Okay.
Exactly. Yeah.
Everyone on the call, if you'd like to unmute your microphone, ask a question, please do so.
Maybe the fire hose was overwhelming.
Yeah.
Will this webinar be, or was it recorded, and will it be available to us?
Yes, Robert, we will be sending all the registered attendees a link to the recording. Yes, you'll get that. I think it comes with maybe a transcript as well.
Yeah. And I'll add to that I think Jacob from NDS is on the call, or at least he's going to watch the recording if not. But I went through some of this with Jacob a couple of days ago, and I've only been using NDS like solid for a year. I mean, I took a year to change from amps to NDS, and so yeah, if I know you on the call and you need to call me after and show me 3 things that is going to save me a bunch of time, then please don't hesitate. There's a lot of different ways to use these tools, and I'm sure that I'm not doing it the best way, and it could be somebody at NDS would have some better ideas on some of that part.
I have a question. This is Lucas Rebello from IDSIL. Great presentation for you both. Maybe to Mark, how sensitive is the cost minimizing optimization to small changes in the feed ingredient prices?
Well, I mean, it's just looking at numbers, right? And so, Steve was sort of showing you how to get a shadow cost out of LPs, which is a really good thing with them. And, if it's 1 cent out, it takes it out, right? And so if you add, get it 1 cent cheaper, it puts it back in. So, on the margin, it's sensitive to it. In real life, how important is that? Well, probably not that important, right? I mean, I think you have to look at a lot of those numbers that way. Remember, all that biology has numbers that we put on it, but all those numbers have variance around them, right? We don't know them all 100% down to the 5th decimal point. Those amino acid slopes that I was showing you, that standard errors was in that slide. Okay, they're 20 or 25% standard errors. So yeah, I'm pretty sure methionine is around 2 grams of protein per 1 gram of metabolizable methionine, but it could be 1.8 and it could be 2.2, and those are pretty big differences, right? Particularly if you're at a sale wanting to sell methionine, that makes a big difference. So.
Yeah, Lucas, that's a good question, and we can dig into it as you and I work together going forward. But I feel like if I got a ration that we're feeding and I optimize it and I find 6 or 7 cents of feed cost, if I look at those 2 rations side by side and I feel like in my heart that I can put this ration in the bunk and expect the same or better production than we have today, then I think that 5 or 6 cents or 7 cents of savings is a great opportunity. And also you look at 5 or 6 or 7 or 10 cents as a percentage of total feed cost. It's not a really big percent at all. It's a pretty small number. But Peter Yoder challenged me the other day. He said, what you really ought to do is you really ought to look at that cost savings as a percentage of margin, because that's really what it's moving. So if you look at what margin per cow is, and you add 10 or 15 cents to that, the percentage increase in margin is sizable. And so that was a kind of a new thought to me, and it gave me on smaller dairies sometimes 5 or 10 or 12 cents. It's like it's just not that much. But the larger the dairy, the more number of days, next thing you know, you have enough money to buy a silage chopper. And that I just think it's real.
But I think too, this is a comment Steve made to sort of make his argument, and I don't disagree, but we tend to, when feed prices get high and margins get low, then all of a sudden we're looking for all these savings, okay? Well, that nickel is still worth a nickel when feed prices are cheap and milk prices are high, okay? So, we should be looking for those every day, not just when things get sort of tight.
Yeah. Yeah.
Okay. Are there other questions?
Or comments?
Yes, absolutely. Yeah, they may have another perspective.
Maybe I might have another question. More so thought that might definitely make no sense but maybe to get your perspective, does it make sense to incorporate variability in nutrient composition of feed, such as forages, into the optimization process to some extent, give it some boundaries, give it some more flexibility to some of these ingredients that are more variable? It's not currently implemented nowadays, but do you see this as any potential for future?
You mean like to put more of a worst cost scenario on an ingredient to make sure that if it's less than you think it is, that you still made the right decision? Is that what you're thinking, Lucas?
Kind of, yeah.
I mean, we do that on protein levels of hay all the time. And if you don't feed a lot of hay, then bless you. But if you feed a lot of hay and you see these protein numbers move around, I am careful to not see a 25% protein on a haylage sample and think, oh, this is amazing, and put it in at 25. Now, if I get it 4 in a row from the lab, maybe I'll do it. But I think you just have to know the cows and know the results of what's going on in the dairy right now as to whether you decide you need to shave back on any of that. But I've become more of a fan of TMR testing than I used to be. It's still a kind of a crapshoot, but it's just one more opinion on, are we actually feeding what we think we're feeding?
I think from to add to that comment, the economists, of course, love those kind of problems, right? I mean, because when you start looking at money markets and things like that, they have to consider risk as well. And so there's a lot of literature on that, from other fields regarding how to include an estimate of the variance or of the risk that you're taking with an ingredient. We don't use it in ag because it's also computationally more expensive. And so we're constantly struggling with, I want this diet in 30 seconds and I want it to be perfect. Okay. And I don't, as you add those additional things in, it adds more time and effort required. But it's not that we can't do it. And I'm not saying that we shouldn't do it, because, there are risky ingredients and they might have really good value, but we need to recognize that risk.
And we haven't talked anything about like anti-nutritional factors that could be in feeds as well. How do you optimize wheat silage that has butyric acid in it? Well, you just limit the feed rate of it so it doesn't, so you dilute it. And so I don't think we can solve every potential opportunity or risk mitigation with the optimizer. I just think it takes all those things that inherently by feeding cows, the things you need to worry about, and you take that blend of your own personal approach to that, and then you use the model and the optimizer to help you accomplish that for the lowest cost that you can.
Yeah. Thank you for the thoughts. Thank you.
Are there any other questions? Comments? Okay, well, if they're not, Mark and Steve,
can I ask I'm going to ask a question to the group real quick. So you see I don't know if this, I would like to know whether people would like to see the same thing done for nonlinear. And if so, we can't do it tomorrow because we're not ready, but I would like to know if there's interest. And so I don't know the best way to poll that. I don't know if you can, if I click raise my hand, does it show how many, if you click raise your hand, does it add up numbers, Jill? Somebody else click raise hand and see if it starts adding. Yeah.
Oh,
So yeah,
it shows. Yeah, it shows.
if you would like to see this same thing done in a in the nonlinear model, then yeah, let us know. I mean, we're probably going to do it anyway, but I guess I'm just interested to know how many people want
Yeah.
to, because I need to be better at it. I fiddle with it, and then I just find myself as get excited about it for a little while, and then I end back up kind of with what I showed you what I'm doing today.
Great.
So,
Well, our plan is to continue on with additional kind of series of webinars where we focus more on each of the individual software packages, and we'll find the kind of the combination of groups that can help us or people that can help us with that. But yeah, this is very helpful. Again, thanks, Mark and Steve, for presenting today and providing a lot of great knowledge and practical experience. And I've learned a lot again. So thank you. And I hope the group enjoyed it as well. And with that, everyone enjoy the rest of your day.
all right. Thank y'all.
Thank you.